In a previous video, I talked about some helpful tips for beginners in Go. In this video, I'll be showing 4 more tips that are a little more advanced but will help take your Go code to the next level. Object-oriented programming is based on the concept of representing real-world data in code using what's known as a class. OOP has several features it uses to do this, like classes, objects, and some programming concepts that make working with classes easier. Go, however, is not an object-oriented language, so it does not have these features, but it does provide similar features to them to try and minimize the drawbacks of object-oriented programming. Structs are one way we can make custom types in Go. They are used to group related data together and are similar to a class. Unlike a class, we don't need to use a constructor when using a struct. We manually set the fields. There is no such thing as a required or optional field in a struct. Struct fields work like variables. A field that starts with a lowercase letter is private and not accessible outside the package the struct was defined in. Classes generally have methods, which are functions that belong to a class, that perform tasks on the data in it. In Go, a function receiver is used to add a method to a struct. In this example, we have a student struct, and we've added a full name method to it by using a function receiver. The full name method can only be called by variables with a student type. Interfaces are how we achieve polymorphism, one of the concepts of OOP. Go does contain interfaces, but they are less explicit than in OOP languages. In Go, interfaces are not explicitly implemented by a struct, like they are in Java. They are used to define what functions a type must implement. Let's say we have 2 structs, a student and an animal. The student struct has a method called sayHello, which just returns the string hello. We also have a function called speak, but we want to make sure that anything passed into the speak function has a sayHello function, so we use an interface. The interface makes sure that for anything to be a speaker, it must have a sayHello function that returns a string. If we try to pass the student struct into the speak function, it will work normally, since the student has a sayHello method. But if we try to pass an animal into the speak function, it will not work, since the animal does not have any sayHello function. Composition is used to add a struct's fields and methods to another struct. It is Go's version of inheritance, another OOP concept. Here we have a person struct, with a first name, last name, and an age. Person also has access to a method called full name. We also have a student struct, but since student is also a person, we can just use composition and put a person inside of student. Now, when creating a student, we also have to create a person struct inside of it. But thanks to composition, student now has access to the person's data, such as age and its methods, full name. The empty interface can be used to represent any type in Go. The reason this works is because of what an interface is in Go. As mentioned earlier, an interface specifies what functions a type has to have to satisfy the interface. If we don't specify any functions in the interface, it means every type will satisfy it. If we look at the speaker example from before, speaker specifies that for something to be a speaker, it must have a sayHello function. If we remove this requirement, it means that anything can be a speaker, but now we can't guarantee what methods the value passed in has. The empty interface is often used in maps to allow them to use any type as the value. This map can store any type as a value, but the key must be a string. This comes in handy when we want to store data but we don't know what it looks like, such as a JSON object. A map using the empty interface could store the JSON data, making it useful when calling APIs. There is a catch when using the empty interface, however. It doesn't mean we can just bypass using types. If we want to use a variable defined in an empty interface, we need to use type assertion or casting to state the value's type. To use the variable v here as a string, we first need to cast it, so that Go knows that the value is a string. If the value was not a string, we will get an error when casting. We can also use a type switch if we don't know the value's type. Like many other languages, a function in Go is a type. This means they can be assigned to variables, passed as parameters, returned from functions, and stored in data structures like any other type. Normally, we define functions like so, using the func keyword. But since a function is a type, we can create a function like we would any other variable, using type inference. Or if we don't want to give it a value yet, we can just define a variable with a function type. Since a function is like any other variable, it means it can be passed as parameters to functions. Here, we are passing in an operation function that will perform an operation on the other two numbers passed in. When working with functions as types, it is common to save the function's parameters and return types to another type. This is like creating an alias for the function. Here, math operation just stands for a function that takes in two integers and returns an integer. In this second example, we can see that we can also store functions in arrays and also return them from other functions. Here, I want to return a random operation function from another function. To do this, we're going to store all our operation functions in an array. And then, in the function, we'll randomly pick one of the entries in the array and return it. Import cycles are when packages import each other, forming an endless loop of imports. Something to be aware of when designing your project is these are not allowed in Go. The compiler explicitly does not allow this, and won't compile if there is an import cycle. No matter how many imports are in the loop, if it detects a loop, it will cause an error.